So this part of our feature presentation on performance addresses the plan for measuring whether we accomplished benefits and changes in performance that we expected to see post-deployment of new capabilities. So TBO Analytics is a new tool that we have been developing for years now. MITRE is on the front end of development of this tool. And as they add new capabilities, the tool is being transferred to the FAA for warehousing and maintenance. So on the next slide, what are we talking about? Just a reminder that this part of presentation builds on the foundation we built in the previous industry days, TBO industry days, back in the day when we talked about trade-offs between throughput, flight efficiency, predictability, and flexibility, when we discussed metrics that we believed were the key to our understanding of performance within each of the key performance areas and so forth. This is the tool that basically draws from those exchanges and those conversations and that we are ready to share with you now. So on the next slide, before we even go into demo piece, we want to emphasize some key points about this tool. First of all, we are incredibly proud to share this with you because it's the first time that we have accomplished integration of data from different data sources, from different systems. And that integration is pretty much automated now. We are done with validation. All the elements, all the connections that we build work fine. It's increasingly more difficult to find errors. In fact, we have not found any errors recently. So that's definitely a pride moment for the team because it was incredibly complicated. And Dave Raymond will tell you a little more about the elements that have been integrated so far. So in the past, analysis like this, like the metrics that you can now pull from the TBO Analytics website, took weeks or even months to generate because one had to go back to the individual data sources, merge the data sources, ensure that the merging is done properly, and then start analysis. In addition to all of that, the tool is already capable of controlling for some key non-TBO factors like demand or volume or congestion and so forth. You'll see examples of that as well. So when we talk about average behavior, it's not average across both busy and non-busy periods, which provide very fuzzy picture, but you can see what happens during busy periods separately from what happened during other periods in a day. In addition to that, the tool from the very beginning was meant to satisfy the needs of a very broad range of audiences and reporting needs. What do I mean by that? From executives down to the people in the field, to the operations, there are elements that have already been developed, and we will share them with you, that provide value to those different teams. Now, clearly executives do not have the same performance reporting needs as field may have, but what we did manage to accomplish, and it wasn't a small undertaking by any stretch of imagination, is connect the dots between that executive high level all the way down to the very detailed deep level analysis that ops may be interested in. So the connectivity vertically and horizontally is established and validated, and beyond proud of that. As we said earlier, we share data with you through NCF forum, various SNAC meetings, NIVIGs, many other. Call for safety will include bits and pieces on performance soon as well. And what I really do want to emphasize is that reporting is complementary across the board, standardized across the board. We are all pulling from the same original, underlying data sources, and simply taking slightly different roads to better address a particular performance reporting need. But if it's the same metric from the same data source, same time period, whether you're using platform A or platform B, it's all the same. You're going to get the same result. Very proud of that, because that was a formidable undertaking, and we have validated the reporting. All of that being said, the tool is living tool, which means it's a foundation that we will continue building on going forward, and bits and pieces that we will share with you today are really just highlights, nothing more. We have actually put together 3 stations in the reception area to the side, in the break area to the side. On one of those stands, you can play with this tool. There are ways to keep clicking around, although I have to alert you that because we have to be behind firewall, FAA's firewall to you, so there is MITRE network, Wi-Fi connection, FAA firewall, so the tool is saying it's slow, it's a compliment. It's really slower than slow, but in real life, it's actually very fast. So if you need to do this again over Zoom, we can do that, and you can see its true capabilities. One thing before you even ask, we cannot share access to the tool with external stakeholders just yet. We do not have that capability developed yet, and the biggest thing that we need to resolve is the identification of flights. So we are aware that you're going to ask that you will want to, especially when you see how cool it is, want to have access to it, but not until that point in time will we be able to actually give you direct access to the tool. So for now, only behind FAA firewall, internal stakeholders can play around with it. If you see anything on the tool that you would like to be able to study at a greater level of depth, all you need to do is ask. TBO email, I cannot emphasize enough, send us your request, we will pull the data you need and share the charts, but we cannot give you, login information directly. So, next slide, please. Dave, would you like to explain?
All right. So when we first started down this road to building this tool, we knew that data, of course, is going to be the engine that drove everything. And we knew that the data was somewhat compartmentalized, and that was a big constraint. And the other constraint was what Alma's already mentioned, and that is harmonizing that data and the metrics that come from that data with what the FAA and SysOps and NextGen report. So we stumbled along the way, but we eventually found the solution, and this slide here is kind of a picture of that solution. We pulled individual flight data, and then we also pulled location-specific temporal data in quarter hours in this case, and we had to put them all together. Okay, for the individual flight side, we had to pull operational data from ASPM, as well as TBFM-centric data that kind of measured how the TBFM system was doing things, scheduling things, and then how flights were complying to those. And then also we use a thing called base processing evolution. That's that BPE flight data to assist in areas where ASPM may have been short on operational flight information. On the quarter hour side, we pull from ASPM for cancellations and diversions, and then for go-arounds, we pull from PDARs. I think most people in here are familiar with those data sources. But in the end, we had to put them all together, and we came up with 2 large data sets, one for individual flights and one for locations on a quarter-hour basis. So that's the underlying data that we used. Alma?
On the next slide, are there any questions? We kind of keep moving forward. can address questions as we go too. So this is how the tool looks like when you pull it up, the first time, right? It's the picture you see on the left. So before we go into the demo portion of this briefing, I want to point out that there are several key sections that one is looking at. And the very starting point is something we call airport context. So rather than deep diving immediately into what does the metric show for whatever location, whatever time period you may be interested in, we are slowing you down and we say, hold on, you need to know some key contextual things for that time period, that location, that may actually help you more accurately interpret the data. So getting metric directly may be misleading. You immediately jump to conclusion that something is too high or too low or, somehow not good enough. But the reason is not because of what you're thinking about, not the particular deployment, but something else, right? And I like to joke alignment of planet impacts metric outcomes, but it really does. I mean, the weather we talked about previously, construction projects at airport, there are quite a lot of those things that could be hidden in time ranges you're interested in that you're not aware of. So that airport context slows you down and points out, it doesn't tell you, hey, there was a construction project. We're not that smart. We cannot pull that level of granularity, but you can see that cold rates are lower than normally. So that will be, something is going on, right? A flag for you to look deeper into. So that's that airport context, and we'll go deep, into explanations, into examples later. Then we go into, the end goal of time-based management is to deliver smooth flows as they arrive to their destinations, right? So to our front view, we decided to put TBFM arrival metering system. Going forward, we will be expanding that view somehow logically, but as this is a living tool and work in progress, that was our starting point. Some key metrics with respect to extent to which arrival metering system was used at that location, and some key differentiation of flows in terms of proportions of flights that flew through, that were actively metered versus not for various combinations that matter, such as runway configurations that are called or runway thresholds that each flight landed on, and so forth. And then the meat, right? Operational context. All of those metrics that you see below operational topics of interest header have been developed. Each of those topics has multiple charts, interquartile ranges, tables, whatever it's important to emphasize for one to understand performance with respect to that particular topic of interest. So as standardized as this tool actually is, it is not one size fits all. So each of the metrics is studied and developed in basically not isolation from others, but in a way that best suits interpretation of outcomes for that particular topic of interest. And you can see that one cannot just look at benefits, because benefits can be very much misleading. The fact that, something didn't move as much as you wanted it to move in the direction you thought it should have moved may not be necessarily a sign of lack of progress. It may be a sign that something else was happening at the same time, at the same location, and applicable to the same flows that you were not aware of. And, over the several points earlier today, we talked about performance trade-offs. So we also in the past discussed that those 4 key objectives is pretty much impossible to improve every single one of them at the same time. It's, the give and take between the 4 that will lead us to a better balance in which the system is more efficient. And that's the end state that we are striving to get to. So the topics of interest generally group into the benefits, metrics that tell us something about benefits. metrics that tell us something about use of flow management initiatives and time-based management capabilities, and then additional contextual metrics that help us more accurately interpret metric outcomes and help us err less when looking at those things. On the next page, before we deep dive into the demo, we have Brandon Smith here, who joined us to explain the changes that we implemented, deployed over time at Denver. So when we later discuss changes in performance, you can connect the dots back to the operational improvements we delivered.
Thanks, Alma. My name is Brandon Smith, and I'm the NACA co-lead for the Northwest Mountain TBO TBFM support team. This really is exciting. I know it may not feel like it, but for me it is. I don't typically get to be in the room with the likes of most of you, so most of my time is spent kind of down in the trenches, so to speak, at the field level, at the facilities. And it is really important to understand how difficult it is to connect the dots between the level that they're looking at and how it affects the controller, the traffic management coordinator. And what they're doing here is a really big deal because we don't really have anything like this. And so to kind of conceptualize gains and losses at the facility level is really difficult without understanding every one of those facilities. And so applying that in that way kind of helps you to understand. And so for me, I picked this picture as our starting point because this is kind of our bread and butter. I know it's kind of difficult to see with the contrast and all, but this was actually pulled directly from a TBFM system, and you can see right in the center there is Denver International Airport. And if you look at that blue ring around the outside edges, that's the entirety of the Denver TBFM extended metering system. It's a big system. That blue ring actually runs out about 500 miles from Denver. It's a long way. It's a big system. Like I said, it's actually the biggest system that we've got in operation right now. And it takes up about half of each one of the adjacent facilities, and actually about half of Fort Worth Center too, which is a second tier. It also represents a tremendous effort over several years and countless man hours to fulfill the promise of a system that can meet the needs of this unique operating environment. If you've ever spent any time in Denver, especially at the Denver airport, you know that they deal with extremely high levels of meteorological uncertainty on a daily basis, if that's the nice way to put it. It's pretty crazy out there. And so when we went into Denver and we asked what they needed to be able to extend metering from what they were doing before to full-time metering, they told us that they needed a system that was flexible enough to react to that frequent and rapidly changing weather while still keeping the stability and predictability of time-based metering. So we already had a fair amount of experience at this point, so we knew that we needed to push that system further out. They had an in-house metering system. That inner white ring there represents that system there, but it just couldn't capture the volume that Denver was experiencing. So we knew we needed to push it out further from the airport. But we also knew that an ACM system, which is adjacent center metering, that's what we used in Atlanta and Charlotte, wasn't really going to be a good fit at Denver. It doesn't really provide the flexibility that we needed there. ACM works great a little bit further east. It just takes that structure from the arrival system and it just pushes it out into the adjacent facilities. And it works very well for certain places. but it's pretty rigid. And so in the case of Denver, to be able to reach out there and capture that volume that far out meant that those flights and that structure and that schedule was going to be pretty well locked in from that blue ring all the way to the TRACON boundary. That's about 460 miles. That's a long way when you're talking about air traffic as far as like being able to react to things. And so, that works fine in Atlanta and Charlotte. If you were paying any attention to the video, that's my home. So our adjacents are very accommodating in Atlanta, so they're able to kind of handle that. And the weather's pretty stable, so that worked very well. But in Denver, of course, it does not. And so extended metering casts that similar large net that ACM does that reaches out there and captures that volume. But midway in around that arrival system and that white line, there's sort of this buffer. So what that does is it allows those adjacent centers to have a frozen, stable feed that they can deliver to the arrival system. That buffer zone in the middle kind of allows things to shuffle out before they're frozen again in the arrival system. The arrival host facility, which is Denver Center, of course, takes that schedule, and they're able to deliver that into the TRACON. And it really does give Denver exactly what they need to deliver something that's stable and at the same time somewhat flexible to the TRACON. One of the other things that they really needed, which was mentioned in the video, was lots of options. Denver now has 8 arrival routes, 4 different corners, 8 arrival routes, 6 runways. If you know anything about runways, that's 12 different directions. That's a lot. So we use 29 different runway configurations within TBFM to try to deliver to them all of the different combinations of flows that they need. And they're actually waiting for an upgrade that'll come either end of the year or first of next year so that they can have more. And so accommodating them and being able to do that was part of that delivery. And the other thing that they needed, which we weren't even really sure exactly what they would need, but it's actually worked out very well, is to provide them with additional flexibility. The extended metering environment allows them to turn on and off different components of metering in the places where they need it, so that they really have 4 different combinations where the adjacents can meter or use EDC or departure scheduling, where they can use the departure scheduling, of course, is another component of TBFM that the adjacents can either meter or mile and trail using EDC. Denver Center proper can either meter or mile and trail regardless of what the adjacent centers are doing, or they can do it the old-fashioned way where everybody's departure scheduling into the arrival system, and they're all providing mile and trail when they need kind of that total flexibility. The nice thing about this, or the success of this system and in this environment, is that it really allows Denver Center to stay loose enough to be able to react to those varying conditions while still leveraging metering to some degree or another almost all of the time. And you hear the right tool for the right place at the right time, and that really does sort of exemplify extended metering in Denver. You can go to the next slide. The real kind of beauty, in my opinion, as we've progressed through this process, I was a TBFM SME in Atlanta, a TMA SME in Chicago before that, and then I've been on this team for about 4 years. And so kind of to watch that progression and see how we look at these things. When we went into Denver, we recognized from the operating area sort of concept that we were looking at that time, that to help Denver, we really needed to help Minneapolis, Kansas City, Albuquerque, and Salt Lake Center. And so we did that. We took the time to go into those facilities and ask the questions that they needed answered, and then we followed through on those. That allowed them to sort of want to help us with Denver and fixing the Denver problem, and it also made them more able to do so. And so as we kind of go through that give and take process and we push that out from Denver Center to the adjacents, Denver is also doing the same thing. So Denver helps Albuquerque and Salt Lake Center with metering to Phoenix and Salt Lake City, and soon they're going to be asked to do more. And we are constantly, as we've been talking about throughout the day, we're adding integration tools like IDAC and T2T across the NAS. There are other markets that we're looking to expand TBFM into, markets that are asking for our help, and they can't wait for us to get there. And so, of course, these systems, when I first started, they were looked at the center level, and that wasn't large enough. So we moved out kind of to this sort of picture where we were looking at the operating areas. But even that doesn't really capture how interconnected they are. And so what we offer is a predictability and a stability, this information exchange that really it kind of isn't. It's kind of difficult to look at the picture and tell. But I can tell you from the facility level, they can feel it, and they know that it's better. It feels like a win to them. It feels like a win to the facility, the workforce, and I would say, not speaking for you, but from the stakeholder standpoint, as far as all of the information that we're getting at the facility level, it feels like a win for the stakeholders, and so trying to connect that to some quantifiable numbers is really kind of cool for me, because I can go into the facilities and I can tell you it's going to be better all day long. I know from experience that it's going to be better. Trying to convince them of that is really, really difficult. Every time we go in, it's the same thing. So, but I can tell you that we deployed this system in Denver in October of last year. I was just there 2 weeks ago. We've moved to a sustainment posture there. So I've only been there once since we deployed, and when I talked to the union reps, TMU, and the supervisors and all of that, they're actually happy, at least with TBFM. And I will tell you that it is very satisfying to walk out of a facility and feel like they're better off than they were when I walked in. And that's what we're able to provide. And so being able to connect those dots and put some numbers and quantify those things is really kind of an exciting time for the operational air traffic side. And that's why I love being a part of this. Thanks.
Thank you, Brandon. So I want to draw your attention to something Brandon said several times, which is a solution for Atlanta is probably not going to work for Denver or LAX. If it does, by all means, we'll implement it into places. But if it doesn't, it's the right tool being deployed at the right place and used at the right time that we are trying to accomplish. And at the very beginning of the day, we showed a 15-minute video on exactly that contrasts and compares those solutions between Mid-Atlantic, Northwest Mountain, and Southwest operating areas already. We posted the video on TBO website, so you can go back and watch it when you have the time. But those subtle differences in how to tackle these challenges that are location specific have been described in the video. So what did we hope to accomplish in Denver? With the introduction of extended metering and many tweaks to arrival metering adaptation, with the procedural improvements that were delivered in the same space, we were hoping that delays previously experienced in terminal area would not be as high inside terminal airspace. Some of it would have been shifted further back upstream. We were hoping to see increased use of departure scheduling at origin points for flows into Denver, wherever those capabilities are available, right? Not every origin use the capability. Not every one of them has IDAC, but where they do, we hope to see increased use. Of course, study delays, see what's going on there, delay assignments, as well as compliance to the times. We also expected to see lesser use of MIT restrictions. And those are the key points that we would like to demo today. So how does our TBO analytics look at those issues? So on the next slide, it's just a quick summary of what I said. We can deep dive into the demo itself. So what you see here is the opening page of the TBO analytics demo. Right now, it's designed to look at the first 4 operating areas. These are the focal airports at the first 4 operating areas. We are focusing on Denver, of course, but the same capability exists across the other 6 sites. One of the improvements that we are looking at is expanding this list onto ultimately all of the 52 sites we discussed earlier today. There are 2 periods, start and end time for period 1. This would be pre-deployment, and start and end point in time for post-deployment of whatever capability we would like to investigate impacts from. What you see here is time before XM, time before Metroplex improvements, time before procedural changes and everything else that happened, being compared to a most recent winter time when both demand came back up in a little more significant ways, and all of those capabilities were fully deployed and operational. We are focusing on reportable hours just because, what happens during those hours is a little more meaningful than what happens in the middle of the night. But if needed, one can select a full 24-hour time period. So everything below that, if it's blue, it's pre, if it's orange, it's post. And first, airport context. Why is this important? The very first thing that comes to mind, Brendan just said, many runway configurations that matter, right? So if you were to look at sequencing delays immediately and look at change between period 1 and period 2 without actually noticing significant flop in north and south configuration at Denver between period 1 and 2, you could accidentally make a wrong conclusion, because some of the change in performance is driven by the fact that now, the opposite flow is dominating the period 2, whereas the opposite is true for period 1, right? So that's a very nice example of context matters. And while we cannot tell you the marginal contribution of south versus north flow and changes in that, we can wave that flag in front of you, so you're that much more careful when interpreting the metrics in the charts below. Cold rates, no significant differences, although there is a little more, bars on the right. The biggest differences in these normalized cancellations, as there are quite a few more in period 2 than period 1. No judgment here whatsoever. We are simply stating, like a good journalist, right, what we observe that matters and contributes to performance, so the interpretation of that performance is that much more accurate. Beautiful chart here in the middle of your screen where we paint throughput on a quarter-hour level. In Zulu time. So this is average quarter hour throughput. So each period, each dot on these lines draws values for the same quarter hour period over the whole period 1 and period 2. So the amount of calculations that takes place is enormous. The chart below it, as complicated as it looks, it's actually very simple. Each dot is a day in period 1 and period 2. And it tells you how many flights arrived to Denver on that day. So how closely these dots fall next to each other really starts painting picture of those typical volume, daily arrival volumes that we observe at Denver. So why do I like this picture so much? It's because it tells you that when you look at immediately before COVID and compare the same time period to immediately post-COVID, we still have catching up to do. Demand did go back up in significant ways, but it didn't exceed the pre-COVID level. Now, if you're looking at trending over multiple years and go back to 2017 or even prior to that, the story would be very different. So this is something I really want to emphasize over and over, bring to your attention, because some of the reporting in NCF is talking about Denver operating at 107%, of pre-COVID levels, and those are all true and valid numbers. It's just that they look at different time periods because the purpose of that reporting is different. But immediately before and immediately after, same winter period, 2 years apart, you can see that we are operating at about 50 flights per day less, fewer than before. So that's that airport context at a high level. When we deep dive into arrival metering, we can see, first of all, that meter fixes are not in exactly the same place as they used to be. So there was some redesigning of the whole system and setup. But the most beautiful part is this chart over here in the upper right, where you can clearly see that metering is now used consistently throughout the day, where previously we had kind of two peaks. We had a morning rush and afternoon rush, but now a lot longer per day. You see the same kind of view in the chart in the middle of the screen. Each dot is how many hours per day on any particular day the system was actively used. So you can have box and whiskers. This is your 25th to 75th percentile. So typically between, 5 and 7 hours per day, with the maximum going to 11 pre-COVID, but now between 11 and 12 hours per day, with average smack in between those two numbers. So clearly increased use, distribution of flights by meter fix, by arrival runway configuration as it's called and reflected in NTML, by threshold over which arrival landed. All of these charts are embedded, as you can see, so you can scroll up and down to see all of the possible combinations and comparisons. Darker part is metered, lighter shade is not metered flights, orange is still post, blue is still pre. Those are the highlights for TBFM arrival metering system use, and then operational topics of interest at the bottom, grouped in 3 sections as described before. So instead of clicking on one of these buttons, which will make you fall asleep, before the new screen shows up because of multiple connections points that have to be established, we are cheating a little bit. So we have browsers that, imagine I clicked on sequencing delay. This is what would show up. So sequencing delays at Denver refer to that difference between nominal time that aircraft is expected to fly from the meter fix to the landing threshold, the threshold of the landing arrival runway, right? We have categorized information by gate, meter fix, arrival runway, presented in distribution kind of fashion, as well as in tabular fashion with nominal times clearly visible in the table on the right. So why is nominal time longer in period 2? It's because speeds are slower. We confirmed that. Initially, we were like a little, alarmed by that finding until, it actually did make sense. So the procedural changes included speed assignments that are lower that result in longer times. But as you can see on the top of the screen, the sequencing delay, the value of actual flown time inside terminal airspace, on top of that nominal for the correct flow, which is meter fixed runway threshold combination, those values did go down. They went down a little less than 2%, which is equivalent to 2 seconds weighted average across everything. It's a lot bigger than that for some flows, a lot less than that for others, but when you draw that line under everything, it is an improvement. The weighted nominal time is higher for those speed reasons. The chart that Dave Knorr mentioned earlier today, this is something we are really proud of. This thinking came out of NextGen office, and it took several years for us to come up with a simple representation of the idea. But the idea captures two different things at the same time. First of all, sequencing delay is a function of congestion in terminal airspace. The higher the congestion, the higher the delay. It's very intuitive, but as Kurt said earlier today, when you see those intuitive thoughts demonstrated in your data and charts, it's super exciting. So it may not be as obvious, but there is an inclining curve, line here, which, if you connect the blue to blue to blue or orange to orange to orange, there would be a very ever so slight increase in sequencing delay with increased congestion rates. But what's also exciting is for the same level of congestion, compare delay to each other between the two time periods. And you can see that in some of these cases, the medians are still very much aligned, but the range is not as wide, or the outliers are not as high, and so forth. And those are the types of improvements that we hope to achieve with being able to manage flows better, to deliver them with higher levels of predictability to meter fixes, and then from meter fixes all the way down to the threshold. So this is one example. Another example would be MIT. We talked about, MIT use would decrease as a result of improved time management, and it sure did. For arrivals to Denver, you can see previously we were using anywhere from 3 or 5 to 8 restrictions per day, but now in the same time span, same season, we are using up to 2 restrictions per day typically. The maximum numbers we observe per day is 3, whereas the maximum previously is 12. So absolutely fewer restrictions. When we do use MITs, their duration is very similar. So when we need restriction, the application of restriction is fairly similar, both in how long they last and what MIT values are applied. But because of the fewer restrictions, improvement is quite visible. This is the chart that Kurt mentioned earlier. It's requesting ARTC and providing ARTC and daily stringency values, average daily values for each combination. And for period 1 and period 2, and on the bottom, it's the difference between the two. Kurt, help, please.
I think you did good.
So what we see here is ZAU requesting restrictions that are provided in Indy. ARTC increased from average daily stringency just below 9 to 25, but for every other combination, we see a serious decrease. So I can read these numbers, I can explain the chart, but I cannot provide operational context. I could use help with that.
So stringency is basically a multiple of the duration of the restriction and the mile and trail restriction itself. So if you see a reduction, we're putting out either smaller mile and trail or less duration to the mile and trail from center to center. So, and I don't have my glasses, so I'm trying to focus here. So Indy looks like they're providing more mile and trail to Chicago than before. And I would probably expect that, right? As you push out those metering environments, as Brandon mentioned, before some of that mile and trail was just absorbed in the first tier centers. But now, as they have to meet some metering delays, they might pass that back or precondition the metering environment with some miles and trail from maybe second tier centers. So that kind of makes sense to me.
Just one more example of departure scheduling. We talked about departure scheduling use increasing, right? So, and pretty soon you will see that that's the case. Not only did the use of departure scheduling at origin stations for arrivals to Denver increased, but the delay assignments have shifted towards the lower side of delays, and compliance increased as well. Again, the charts that are shown at this side of the TBO Analytics website are appropriate for these kinds of analysis. So at a very high level, it looks like, delay didn't change much. Compliance really increased, a bit, but the charts on the bottom is where they show that really nice picture where delay assignments, these very, very large delays are going down, medium delays, and compliance moving in the right direction. What's really interesting here is this bottom part where we can actually study the extent to which TBFM departure scheduling is used by origin station and proportion of flights that were departure scheduled to begin with. And what I completely forgot to say, which I should have, is that each of these pages on top has its own filtering capabilities that are appropriate for this particular topic of interest. So within the two time periods for arrivals to whatever the airports you selected on the main page, now you can go deeper and say, well, I'm not interested in everything to Denver, but only in certain origins. Or I want to study based on the distance between Denver and origin, or whose departure scheduling facility or what mode of departure scheduling was used, like, EDC, arrival system, XM, is it IDAC or TGUI and so forth. So those are all different options that, for executives, they may be interested in this level. Operational people are looking already at more granular data being displayed or some conditions that are of the interest to them at a given point. I don't dare to select and hit apply. It all works. You're going to have to trust me on it, but I would rather go through that level of demoing when we have a better connection. So in addition to these three metrics that we showed, we will be incorporating metrics that are of interest to airlines, A0, D0, A15, D15 at a minimum, some other metrics. That's work in progress. As Dave explained earlier, we have just validated our connections and data, mapping and increasing capabilities as we go forward. So the next few slides, very quickly, examples of things that we are thinking about adding. This is something that Kurt and his team have been working on.
Yeah, so we built this dashboard over the last year or so with the performance analysis group within SysOps. The intent of it originally was to be able to measure filed versus flown, so we could kind of start to quantify the impacts that our TMIs impose on the users. We also have scheduling delay associated in here as well, because that is also an impact as we hold people on the ground to try to get into the overhead stream. And this is just a kind of one picture out of this page that you'll be able to actually go demo when you go out in the hall after this is over. This is available to industry. This is on the TM Efficiency Toolbox, the industry TM Efficiency Toolbox. The call signs, of course, are removed, but you will be able to access this when you go home tonight if you'd like to play around with it. We do have an internal version, which you have to be inside the firewall, that actually has call signs so that, traffic management officers can kind of dig deeper into their operations. But basically, this page that you have up here, you can compare two different time periods. And so you can select for, let's say, Denver, pre-Metroplex and pre-extended metering, and compare it to now, and actually kind of see what the benefits are, or what the trade-offs are, if you will, between the filed versus flown, which is, you can sort it by your scheduled filed flight plan, the first filed flight plan, the last filed plan, flight plan, to what the actual airplane flew. And then you can also compare the scheduling delay. So sometimes when you move from a mile and trail environment to a metering environment, some of those trade-offs are, or could potentially be, maybe longer delays on the ground versus being vectored around in the air. So the page will also show you kind of the banking behaviors into the airport. And it's all color coded by impact. So basically, the higher the impact, whether it's vectored for 40 miles or more, let's say, or kept on the ground for 20 minutes, it'll be color coded by that impact. So you can visually see basically the impact also on the scale. So we thought this was actually a pretty good tool that we could bring into our TBFM analysis. Like I mentioned, it is one of our Focus 5 this year, so that we could kind of compare time periods of pre-metering environments when you're using Mile and Trail to actually when you're using TBFM. So we started adding some enhancements to it, where we're starting to look at corner post impacts, so that we, because we all know that you could actually overload a corner post and not ever get to the arrival rate, but yet you have impacts to those airplanes on that arrival corner post. So we wanted to kind of analyze that, kind of see the peaks and valley in the demand profile as well. So quite a bit of information on this. You can select a particular day, you can select a range of days, all Thursdays, whatever you'd like to kind of look at, or you can kind of do a comparison analysis that you see up here. And again, we'll be out in the hall after this is all over, and we'll be glad to show this to you if you guys want to see a little bit more of it.
So out in the hall, we have 3 stations set up for you, for everybody who can stay longer after Industry Day. One station has more information on metrics and methodologies. Dave North's team is manning it. Another station will provide you opportunity to play with the ATO efficiency for industry, which includes this link. Kurt and Dave Raymond's team are there. And the third station is TBO Analytics, what we are demoing here. So you can keep clicking. Hopefully it won't spin too long before it shows you what you're looking for. But again, we can do this online later on as well. On the next slide. Thank you, Kurt. This is something that Patrick and his team referred to earlier today. Patrick?
Yeah, so as I was talking about with Denver and LAX, and so if we look at Denver first, right in the middle of it, you see right around September, October timeframe, Denver's averaging around 2,500 RNP usage, or RNP approaches per month. And then as I was talking about, as we conditioned the flow, we introduced XM along with the chart notes to slow down the speeds into the Tracon. We're getting more predictability, and in turn using the CRDA functionality along with the better flow, you see October on, now we're averaging 3,500 to 4,000. every month now because of that. The last 2 months, obviously, as it shows there, it's just because 1/6 right's been closed for construction, and that's one of the main runways for the RNP usage. And then if we focus on LAX, it's kind of the same thing we talked about that Phil touched on. Once we implemented EOR, established on RNP authorization for the simultaneous independent approaches for the west flow for the 2.4s and 2.5s, we implemented CRDA right around August, and then we received authorization in September. So as you can see, just from conditioning a flow with CRDA, we were averaging, I think it says 12 there, but every month before that was about the same. They've had these RNP approaches forever. They just didn't have a tool like CRDA along with the ability to do simultaneous independent approaches. So August, it already shot up to around 200. And then once we obtained the EOR authorization, they could use it even more because now they're not staggering. And now we're, averaging 400 to 600. I think I just saw August's notes. I think they're back in the 600s for this last month. So it's just showing, the correlation with TBO. It's time-based along with PBN, and these two operating areas are showing the maximum, the benefit that we're seeing out of it and how it coincides from TBFM over to PBN.
Thank you, Patrick. First of all, I apologize for one of the text boxes running to the right. It should have stayed on the Denver side, but we'll correct that slide later. This is something that doesn't live. Yes, Lee?
I just have some questions about, so we see lots of different data. We see lots of data from different sources on RMP usage and EOR usage. The information that you're showing here, is this the same data that we get from the Ted Goodland source?
Yes. So this is his exact slides. Yeah.
And how does this tie in with what was just presented at the NAC by the Section 547 team?
These, I believe, this was the same exact.
The same.
Yeah,
so
same
data.
exact. And his notes is showing only if it's in a period where we're in IMC conditions too. Yeah. So their actual usage is even higher.
Okay, all right, so we're all aligned. It's all coming from the same place.
Yep.
Great, thanks.
It's a great question, and that is true. The aligned across the board is true for not just PBN, but TBFM, ASPM data, and even flow trajectories are mined in more or less the same way. So what I was going to point out, these two examples that you saw do not live on TBO Analytics just yet, but this is something we are considering to add to the page because right now we have nothing on PBN News. We're actually considering to add something differently, very well aligned with it, but on the next page, we think that focusing on proportion of equipped overlap with proportion of flights that are in position to use approaches, so those on downwinds and in position to fly. Straight ins, I do not believe are accounted for here, but this is notional. Take this, as a thinking behind the ideas we would like to capture. So thinking in terms of that Venn diagram, so you can keep track of how things jive together. And then finally, that dark spot in the middle that has grown to 3% will hopefully grow to a larger number soon, is equipped, in position to use, and actually flown the approach as well. I like this because I think it's very easy to understand and read it, but generating something like this from existing data is not straightforward. So this will take time to build. The next slide, we have just a couple of more examples.
More questions. Sorry. When you have equipped, especially when we're talking about RMPAR, you're assuming equipped and trained because that affects crew, right? How are you getting that information? Is that, equipped, is it based on what we're providing in terms of who's eligible? Not my company, but I can't speak for anybody else. All right, so we're going off of who files. Filed, okay.
So in summary, I thought we had a few more examples, but we don't, and we took way too much more time than we thought we would. Anyway, if you're going to walk away with anything again from this part of our presentation is that the foundation is built. We already have quite a few elements that are adding value that have been flushed, negotiated to no end and agreed upon, and now being generated and displayed in exactly that shape and form that we thought would add value for a wide range of reporting needs, from executive high on top all the way down to operational use. And probably the most important part, this is a living tool. So, and it's going to only get better with use, and it's only going to get better with serious feedback that we can act on. So don't be shy.
Okay, more questions. And it's my fault because I was out on a call, I think, when you all started. In terms of external access to the data and the information, is that going to be something that we're going to see rolled out through the work we do with Kurt on the dashboard, or is it going to stay a request receive from a data perspective, or what's the thoughts?
So for now, we are not ready to allow direct access to this analytics tool to external stakeholders for several reasons. One is the management of it, but also the identification of flights has not happened. So it's something we have to continue working on. Between now and then, right, that moment in the future, send us what you need. We'll pull it up and share a chart with you rather than give you direct access for you to pull the chart yourself. So we're absolutely willing to share the data. It's just that we cannot give you access to the tool. Does that help?
It's an answer.
And Lee, the filed versus flown is available.
Yes,
on it. Okay.
That part. That's why I was kind of hoping we would maybe see some evolution into that platform that those of us that have been in there understand and know how to work. And so if anything, Alma, I would say not to overwhelm what is already going on in the dashboard arena. But Kurt's team has done a great job in terms of working with us in that interface. And I would say that's probably that's an opportunity.
Oh, absolutely. And I think that the development efforts continue in parallelly. It's not that Kurt is going to stop working on filed versus flown if we add it to our dashboard. Not at all. It's because the focus of each side is slightly different. Both add value in different ways, and they're synchronized. So, but, the steps we're taking may not be completely the same.
And requests should go to the TBO address?
Yes.
Not to you personally.
Yes.
See what he's saying, TBO. Yeah.
And just real quick, a quick plug for the team efficiency toolbox. There's a lot of different tools in there, like Lee just mentioned. It's got the AVMET weather impact scores that Vern talked about a little bit earlier. It's got our stringency dashboard in there. It's got a bunch of information, a wealth of information, data, all at your fingertips. I know industry has been asking for access to our data. This is kind of our portal to provide that for you all. So again, it'll be open out there, so stop by and check it out.
I would like to thank Elizabeth, Shelby, and the rest of MITRE team on helping us put this content together, develop these tools. We wouldn't be here without them. Jackie, the rest of MITRE team behind this wall, you can't even see them. They made this event possible, right? There are quite a few of them. And Infin, of course, Cole and her team for putting together that great video that I highly encourage you to see. It's quite informative, as well as helping us change our mind on how these slides should look like just about 1,000,002 times. So thank you for your hard work, guys.
Thank you, Alma. Yep. I would also like to thank the MITRE team, and thank you for hosting us as always, and the Infinite team as well. Almira, thank you very much for all the hard work you've done in putting this together. We appreciate it very, very much. All the presenters, thank you. And would like to thank everyone for attending in person and online. It was nice to see everyone, and it's nice to do this in person finally. So appreciate it. I know we'll have more discussions, and we look forward to that. So thank you very much. Lakeisha, you have anything? Good. Okay. Thank you. Have a good day.